So we talked about organizing either categorical data, or we're going to organize what we call quantitative data. So we're going to organize both those types of data tonight. And by organize, the goal is to do this. My goal when I have data is to put it into a manageable type of way to use it. And what I mean by that is this. If I look at, for instance, I'm just going to show you this real quick. If I look at this right here, these right here, this isn't very manageable to me right now, right? I want to make it manageable. And so what I'm going to do is I'm going to organize it. I'm going to organize it by either creating tables or creating graphs. So that's what we're going to talk about tonight, all right? And again, if you want the actual lesson, let me get that too. If you actually want the presentation, there's a presentation for this. Let me get it. I just thought it would be easier to do it with the just using the thing.
You said there was another way to go to the handout, right? Because I keep trying to open it and it doesn't allow me to.
That file that I put in there won't let you open? Or the one on
No,
Blackboard?
it gives me like
What's it saying?
just a lot of words jumbled up.
I got you. Hold on.
I mean, I
All
can
right,
see
hold.
that slide online, but I don't know if there's more to that than just a slide.
You're talking about this slide right here?
Yeah, the slide I found it on
Yeah, I'm not trying to say that slide.
Blackboard, but the
This is what I
handout
dropped
itself
in.
I can't.
The handout should be in Blackboard too.
Where
I
you
dropped
dropping
it
it exactly?
I dropped it in the chat, but let me go make sure it's on the thing too. Hold on. When I did the True Colors personality test with you, right? What kind of data was that we looked at? Can anybody tell me what kind of data that is? If I look at your color, what kind of data is that?
Categorical.
That is categorical data, right? We have created color groups. We put you in the color groups, right? As a matter of fact, when I did that, I'll tell you what the color groups were. The largest group was the orange group. And in that orange group, there were 8 people. Then we had the gold group, which had 7 people. Then we had the green group, which had 6 people. And then there was the blue group, which had 3 people in it. All right. So those are the categories that I created. And now what I want to do with those categories is I want to do what we call analyzing with them, right? In order to analyze them though, I need to organize them in a way that they make sense. And so we're going to organize them by putting them in tables. And then once we have them in a table, we're going to make a graph for that, all right? So when we start off with categorical data, remember categorical data is any data that the data either names, orders, or distinguishes. So in this categorical data, we're either going to name, order, or distinguish. And here I have the colors orange, gold, green, and blue. What am I doing there? What are these variables doing? Are they naming, ordering, or distinguishing?
Distinguishing?
Try it again. Try it again.
Naming.
They're actually naming. We're naming the groups. We name the groups orange, gold, green, and blue. You can think of distinguishing. Distinguishing more, when you think of distinguishing is more some kind of number that doesn't measure a count. Remember that. Distinguish means it doesn't measure a count. For instance, your zip code distinguishes. Your house number distinguishes. Your social security number distinguishes. Your cell phone number distinguishes. It's a number. Distinguishing means that it's a number generally, or alphanumeric. Here, if you have a color, it's going to name. All right. So then if we know what kind of variable is, in particular, we know that it is a order, or a naming variable or a categorical variable. We can display the data through what is known as a frequency table. So we're going to create frequency tables tonight, all right? Frequency tables. And frequency itself Frequency is how often an observation occurs. So it's how often we observe something. So in this case, our frequencies would be go, we observed how many people, or how often did that occur? How many, I mean, oranges. How many oranges did we have?
8.
We had 8 oranges. That's the frequency. Goat would be 7. That's the frequency. Green would be 6. That's your frequency. Blue would be 3. That's your frequency. I got that. So that's what all frequency is. It's just how often something occurs. Now, we're interested in frequency, and we're also interested in this thing that we call relative frequency, right? The relative frequency. If frequency is how often something occurs, relative frequency would be relative to something, how often does something else occur? And in particular, relative frequency is how often an observation occurs with respect to the total. So if we look at our stuff right here, we need to find the total. So 8, 7 is 15, 6 and 3 is 9, that's 15 and 9. That's 24 total people that did this, right? So the 8 is the frequency, 7 is the frequency, 6 is the frequency, 3 is the frequency. Relative frequencies would take each one of these numbers and divide them by 24. Those are going to give me my relative frequency. And we can simplify those into decimals, or into, in this case, if we take a part of something and divide it by its whole, right? A part to a whole, we can actually find a percent. So these are actually, it is a percentage. That's all this is. The relative frequency is just a percentage. It's just a percentage. All right. Now, what we're going to do then is we're going to create a frequency table. And from that frequency table, we're going to find frequencies. And with those frequencies, we're going to find relative frequencies as well. All right. So look at this particular example that I have right here. And it says, many public health efforts are directed toward increasing levels of physical activity. The company data set gives the preferred activities, and they give you the activities of walking, weight training, cycling, gardening, and aerobics of different ethnicities. So this thing that I'm creating right here is called a two-way table. This thing that I'm creating right here is called a two-way table. All right, and it's used to show two different variables. In this case, here's one of my variables, which is race, and the other one is activity. So I'm showing two variables at the same time on a table, all right? And what I need to do is, here are the actual things right here. Here are the actual variables that they have. You notice here it says for each one of these you have, here are all the blacks, here are all the Hispanics, and here are all the whites. I see that. So now we have to go through and organize it into this table right here. So if you look here, if you look at black first, starting with walking, there are, looks like, I gotta do a very good job of separating this, but if you look at walking, you have 1, 2, 3, 4, 5. Yeah, looks like you have 5 right here for your frequency. You look at weights, looks like you have 1, 2 weights. Cycling, you have 1. Gardening, looks like we have 0 gardening. And then aerobics, 1, 2. And so when I do this, when I write all those out right there, right, I'm giving you frequencies. That total column should be the total number of blacks that I have in the sample, right? And how many do I have total there? When I look at that, 5, 2, 1, and 2, that adds up to 10. All right, so first thing. So we're gonna do the same thing for Hispanic and white. So if y'all wanna go ahead and do that, go ahead and knock out Hispanic and white, and I'll do it with you. All right, but I'm not gonna talk to that, but so we have, let's see. So here's what I get for Hispanics: 4 walkers, 3 weight trainers, 0 cyclists, 2 gardeners, and 1 aerobics person. And then for whites, I get 6 walkers, weights, 2 weights, no cyclists. Oh, 1 cyclist, 0 gardeners, and 1 aerobics person. Again, for a total of 10. And now what's nice about this is now we can go down the actual columns and get those frequencies for each activity. So not only do I know the number of people in the sample, right? Not only do I know the rows are giving me the different ethnicities within the sample, right? But now I can go down the columns and get the actual number for the activity. So for this first one, I get 15 walkers, 7 weight people, 2 cyclists, 2 gardeners, and 4 aerobics people. And if I add those numbers up, 15, 7, 2, 2, and 4, right? That should be, it should be 30. And it should add up to whatever this is right here, right? Should add up to those right there. So over here, we're gonna get a 30. There you go. So this is called a two-way table. On a two-way table now, here's what I see. I can see 2 attributes. I can see the race of a particular participant. And I can also see the activity that they preferred, right? Now, a frequency table. This is going to be our frequency table then. We can call this a frequency table, or we can just look at the straight frequency based off. I'm going to do another frequency table based on activity, right? So I've already found these right here. I know that this is 15. This is 7. That's 2. That's 2. And this is 4 for a total of 30, right? If I want to find their relative frequency, the relative frequency is just every frequency divided by the total. So that relative frequency is going to take 15 for the walking people and divided by what number?
30.
30. So when I do 15 divided by 30, what do I get?
1/2.
1/2, or as a decimal, that is
0.5.
0.50.
Oh.
All right. Next one, 7 divided by 30. If I do that, 7 divided by 30 is this right here, 0.233. I'm going to go to 3 decimals. Next one, 2 divided by 30, 0.067. Next one, 2 divided by 30, we know it's 0.067. And then the last one is 4 divided by 30. 0.133. Now, here's what should be true then. If I add up all those frequencies, if I add up all those relative frequencies, because they are percentages, and again, I can write these as percentages. Let me do that, by the way, so you know that they are percentages. Here are the actual percentages. The first one is 50%. The next one would be 23.3%. The next one, 6.7%. The next one, 6.7%. And that last one is 13.3%. Right? And if I want to find out what they should add up to, because they're percentages, they should all add up to what percent, by the way?
100%.
Anybody tell me? 100%. Let's make sure, let's verify. 50 plus 23.3 plus 6.7 plus 6.7 plus 13.3, and we get 100%. So this adds up to 100%, and this one would add up to 1. as a number. So that is going to be how we calculate our frequency and our relative frequency. What is the difference between the frequency and the relative frequency? Somebody tell me, what's the difference? Frequency is what?
How often something occurs.
Just how often it occurs. So we're just counting the frequency. Frequency is what actually happens. I got that. Relative frequency, how's that different? What do we do for relative frequency?
Calculates out of percent.
You divide it out of the actual, make it into a percent, right? So we're going to divide it out of the actual total. That's the only difference, all right? Now, what we're going to do is create graphs with both those, with frequency and relative frequency, all right? And in particular, the first graph we're going to make is going to be the pie chart, which is a very basic graph. And if you look here, it says pie charts are used to show how parts compare to the whole. We want to compare parts to whole. And we're going to do that by using a circle. And the pie represents a circle, which is, does anybody know how big every circle is? How we reference the size of a circle?
360 degrees.
Thank you so much. So the pie represents a circle, which is 360 degrees. The pie represents a circle, which is 360 degrees. Now, we draw these like this, and I've already drawn it for you. But in theory, we're not really going to try to draw a whole lot of pie charts. We're going to look at what we call our slice size. And a slice size represents a part of the circle, or a piece of the circle, or yeah, let's call it a part. A part of the circle. And your slice size is just this right here. It is the relative frequency. It's the relative frequency, also known as a percent. So it's a percent times 360 degrees. So if I want to find the slice size, I take the relative frequency and multiply it by 360 degrees. That's it. That's all I got to do. So if I know all the relative frequencies, for instance, up here, for these different categories, if I know that this walking category is, I'm gonna call it 0.500. The weight category is 0.2, is 0.233. The cycling category is 0.067. The gardening category, 0.067. And the aerobics category was 0.133. Then if I want to find the walking slice size, I'm going to take 0.500 and multiply it by 360. If I multiply 0.5 times 360, what do I get? Can anybody tell me?
180.
180 degrees. So this is just 180 degrees on the slice size. If I want to find the weights category, which I'll call it T weight training, that is 0.233 times 360 degrees. When I multiply that, 0.233 times 360, I get 83.88. I'm going to round it to the nearest whole number, right? The nearest whole number here. So I'm going to go to 84 with that. So this is 84 degrees. If I want to, I can actually write them over here for these, because this is what I'm actually drawing them for. So this one was, that's 180. This one is 84 degrees. Cycling is 0.067
Degrees.
times 360. Anybody got that one already?
24.
Thank you so much. This is 24 degrees. And that also means that gardening is also what?
24 degrees.
Thank you. So that's 0.067 times 360. So that is also 24 degrees. So cycling and gardening are both 24 degrees. And then the last one is going to be my aerobics. And aerobics is 0.133, 48.
Yes.
Thank you
48.
so much. So this is 48 degrees. There we go. And there's all those categories, the slide size category filled in. And so again, remember that this is equal to 1.00, and these should all add up to what number? Which all these degree measures add up to?
360.
360 degrees. Thank you. 360 degrees. Good job. Are we okay with slide sizes on pie charts? Yes or no? We're good with those?
Yes.
Yes.
Yeah, we got that, right? So we understand that the pie chart represents the whole, and we're just finding the slices by taking pieces, but those pieces are relative frequencies multiplied by the degree measure 360. All right, we're there on that, right? A pie chart is a very basic graph. It's one of the most basic graphs. As a matter of fact, when we talk about categorical data, we're drawing very basic graphs. And in particular, the only two graphs we're going to focus on, which are the pie chart, and we're going to focus on the next one, which is the bar chart. And in a bar charts are used to show the frequency or the relative frequency of categories. The height of the bars, the height of the bars. The height of the bars represent the frequency or relative frequency, whichever one you're talking about. All right. And because this is a business class, we're going to focus on what we call a Pareto chart. A Pareto chart. And Pareto charts arrange the frequencies of each category in descending order. They arrange the frequency of each category in descending order, which means you're going to drop down in descending order as you go through. That means that which bar should be which should come first? Your highest bar should always come first, followed by your second highest, your third highest, your fourth highest. We use Pareto charts in business for quality control. And what I mean by that is when I give you, if I give you, you make a certain product, right? And you want to look at how many errors there are in making that product. Well, when I look at that, I want to see whatever category I'm looking at. I want to be able to get a graph that when I look at it, the first thing I see is the highest error, because that's one I want to tackle first. You got that? So we make these Pareto charts. So we're going to create a Pareto chart here for what we just did. And we can do it through the frequency, or we can do it through the relative frequency. And actually, I'm going to think we're going to do it through both, all right? We're going to actually try to do it through both. So let's start with the frequency first. And on the frequency, I don't know if you can see it on yours, but it's on mine. I tried to put a thing on here already. So for this first one, if we want to make a Pareto chart, what category goes first?
Walking.
Walking.
Walking goes first. So let's go with walking first. And then what category comes after walking?
Weights.
Weights. And then, mess that up, come back here. So let's go walking first. Let's do walking. What is the frequency of walking? What was the frequency of walking?
15.
15. So we need to scale this graph up to at least 15. So I'll do it like this. 2, 4, 6, 8, 10, 12, 14, and 16. There you go. So scaling it. So first when walking is at 15. Like this. Walking category, right? The next one would be what?
Weights at 7.
So let's do weights at 7. We call it T. And when you draw bar charts have gaps in between them, by the way. So you need to put gaps in between the bars, and that's at 7. Right? And then the next one would be what?
Aerobics.
Aerobics at 4, right?
Yes.
Followed by cycling and gardening, and whichever order you want to put
Gardening.
those. So let's go cycling. Cycling and cycling's at
2.
2. Thanks. Cycling's at 2, and gardening is also at 2. Notice this graph right here. What are we doing? You can look at it. I see which one is the most prevalent activity. It is walking when I look at it, right? That's why we want to. It's what we call about organizing our data, right? So when we draw this, let me go finish this off real quick for my own sake. There we go. So we draw this. This is our frequency distribution, all right? If I were to draw the relative frequency, how would that change? What would change if I were to draw the relative frequency? Which bar would still be the biggest in a relative frequency distribution?
Walking.
Walking.
Walking would still be the biggest. Which one would be the next biggest? Weight training,
Weight.
followed by aerobics, followed by cycling
Cycling.
and gardening, right? So that's not going to change. They don't change. The bars themselves won't change height. Their heights won't change. What will change if we draw relative frequency? This scale out here will change to the relative frequency. I got that? That's the only thing that's going to change about this. Nothing else will change though. All right. And what I want to do is now, I want to look at this data in Excel. I want to make this graph in Excel. Probably make the pie chart too in Excel. So let's go. If you don't have Excel, the school gives you the opportunity to have Excel. Y'all got that? Does anybody need time to download the Excel or to go get it on the, I think there's an online version from the school. Does anybody need time to do that?
Yeah, I do real quick.
All right, I'll give you about 2 minutes. So take about 2 minutes, open up Excel. Open Excel and then I'll get back to y'all, all right? All right, so what I wanna do is I want to create the second table. Not the, I actually want to create this one. So I want to create, I want the first one because I want you to see the races too, so. I want black, Hispanic, and white. I want the activity listed out: walking, weights, cycling. Hey, I'm on a Mac, so mine may look a little bit different than yours. If you're on a PC or something else, just know that it's pretty much the same stuff though.
Phew.
Bless you.
You said you
Hey,
wanted to
generally,
create,
say that again.
you wanted us to create both.
No, just this one. Just this one will work. I'll just have to pull them. I mean, maybe. I keep saying that. Generally, I would create formulas for all this stuff, but we don't really need to create formulas just yet. Generally, I would actually use like the sum formula to sum everything up. Like I would do this. Sum these up to make sure they were what we said they were. Then I would drag these like that and get those. If you're not used to using formulas, you will be, because I'm gonna use them a lot. I messed up on aerobics. That's why I like formulas. They help you do that. There you go. I messed up on all these. One there. What's this one? 0. There we go. All right. And then the other thing I think I want is relative frequency too. So let's call this, actually call this one frequency. And then we'll call it relative frequency next. Okay, relative frequency, I'm going to take each one of these frequencies and divide by their totals. 0.5, let's see if this works.
Professor,
Yes,
I'm actually new to Excel, and what you're doing, if you do it slowly, I actually want to learn this
I got you. I'll come
formula.
back to it then and show you what I'm going to do.
Okay.
So
thank
look,
you.
what I did, the first formula I did for frequency, I just wanted to add up all of these numbers up here, right? So thank you for pointing. Let me make my screen bigger. When I want to add, I'm using the formula sum. All right. See how I came up? And to do any formula, if you haven't used Excel before, to do any formula, you need to start it off with an equal sign. All right. And so all I'm going to do is I'm going to type in equals sum. And then when you start typing, Excel recognizes if you have an equal sign that you want a formula, and it brings up all of its formulas. And if you want to, you can explore these different formulas at some other point. But right now, I just want to add them all up. So I'm going to use sum, and I'm going to open parentheses. And I want Excel to find the sum of this cell right here, C3, this cell right here, C4, and this cell right here, C6 or C5. So I'm just going to drag them down. It's going to capture all those right there. So Excel is going to find the sum from C3 to C5. When I do that, I get this right here. Now, once you have one formula, I want the same thing to happen here. I want to add up this cell, this cell, this cell. So again, I can type in equals sum, open parentheses, and I want to grab D3, D4, D5. So I'm going to grab these again and drag down, close the parentheses, press enter. That gives me those, right? I can do that for every one of these, but a quicker thing that Excel recognizes, Excel can copy formulas. So if I drag this over here, Excel is just going to just copy all of these formulas where it's adding up all of these different things right there, right? So that gave me every sum, and the sum here is just the frequencies of each preferred activity, right? These are the activities that you're looking at. All right. Now, the next thing I want to do is find relative frequency. I know that to find the relative frequency, I have to divide my frequency right here in this row right here, divide that by the total. So I'm just going to do equals, take this cell, divided by the total cell, which is sitting over here, 30, and I get that. And all I'm going to do is I'm going to copy that formula over. But the problem is when Excel copied that formula over, if you go inspect the rest of the cells, I want to take what was here, C6, in this cell right here, and divide it by this cell, which is H6. I got that. But this, look what Excel did. Excel went to D6, which is what I wanted to do. I want to take this, but I wanted to divide by H6 again. But Excel thinks you want to keep moving over like this, and there's no numbers over here. And that's why it's not doing it correctly there, all right? So we need to fix that. We need to fix that, right? And in order to fix it, here's what I want to do. I want Excel to keep the same H6 for every one of these cells. So if you want it to not move, if you want a cell to stay constant in your formula, you use the dollar sign. So if you put the dollar sign in between it like this and calculate, and now when I drag, that top number is going to change every time to be the right cell, but this next number is always going to be, that did not work.
You put it before the H.
Thanks. That tells Excel that they want you to keep that number constant. Hey, and if any of y'all know anything that I don't know, please inform me, because I'm not an Excel expert. They tell me I got to teach with it though, so I know some stuff about it. I don't want to pretend like I'm an Excel expert, but thank you for helping me with that. So look, that's what you get. They go to percentages again. You can shorten those percentages if you want to by formatting them. I'm not gonna do all that, but these are your percentages. And now I want to create graphs. Go ahead,
Sorry,
I'm listening.
real quick, show that formula one more time that you just used.
C6 divided by, so I get it now, get it. There it goes. C6 divided by the dollar sign H6.
Okay, thank you.
And then when you get that first one, just drag it over to the other ones, all right? All right, so now that we have that, what we're gonna do is I wanna graph this using the graphs I just showed you. So one way I can graph it, let's make the pie chart real quick so you can try to make it. If you highlight this activity, the activities you're looking at, and if you highlight the frequencies, I think you gotta use control. Nope.
You use
gotta
shift.
use shift, yeah. Y'all
Yeah.
use, or it might, on y'all, is it shift or is it command? I mean,
Oh, I
or is
use
it control?
HP, so I think it's
Yeah.
control for Mac.
Yeah, it is. I think it's command for Mac, because I just tried. Yeah, it's command. Try command for Mac, highlight them. You should have an insert up here. Go to insert. You can use recommended charts. And look what it's going to recommend for you. It recognizes that you're trying to match a category with a frequency count. So Excel is going to say we can use any one of these charts. Let's make the first chart we're going to make is going to be the pie chart. And here's the pie chart that we created. All right. There's our pie chart. And you know, if you notice here, if you look, you can do a bunch of things with these pie charts, by the way. You can do a bunch of things with them. In particular, the big thing I want you to do, if you go over to quick layout is some things we're going to do later on, but you can add like the different, see how they added the things for us here? They added our different, they're doing it out of 100%. These are percentages that they're working, right? These are the percentages that they added to it for us with our labels. You can add the, let's see what this one is. Labels at the top. If you do quick layout lets you play with a lot of stuff. I want to do it with the relative frequencies and get to the slice size. I don't know how to do that though. Anyway, so that makes the pie chart for you. I'm showing you this because one of your projects that I know you're going to do in Excel is you got to make different graphs. So I need you to know how to make the different graphs that I'm expecting you to make. So anything that I put time into showing you, please make sure you know how to do it, because you're going to see it again. All right. But this is the pie chart. And again, all I did was I highlight the cells I wanted and I went to insert and it made a pie chart. Now I can do the exact same thing, highlight the cells I want again. So I want these cells. I want these cells and I want these cells right here. And again, I'm going to go to insert and recommended charts. And these are the recommended charts that they have for me. I want the bar chart. This is just a simple bar chart. This is made a bar chart for us. All right. And again, you can play with the formatting options to see different things. You can see the counts added to it. You go to quick layout. Quick layout will do a whole bunch of cool things for you. See what it did right there. It added the counts on top. So you can change them like that if you want to. That's all well and done. All well and dandy, whatever you want to do. But we want to make a Pareto chart. We want a Pareto chart with this data, right? Or actually first, yeah, let's make a Pareto chart first. So with the Pareto chart, we're going to do, you're going to highlight these, and Excel actually has a Pareto chart function. So if you go insert, and it's right here under histogram. So you got to go find this function right here. It's under histogram. But if you come to histogram, you can make a histogram. This right here is called a Pareto chart. If you look there, it says Pareto. Y'all can't see what I'm clicking on, huh? Hey, do y'all see the histogram one? The histogram is right here. Is this one right here? That's a histogram. It looks like a bar chart, but the actual things touch. If you click on that arrow and drop it down, there should be one that says Pareto. Y'all can't see that, but I can see it. And you can see the word Pareto pop up on my screen. So when I do that, Pareto is going to make this into not what I wanted to make it into.
I think it just highlighted the relative frequency numbers at the bottom, not the categories at the top.
Yeah, you're right. Thank you so much for catching that for me. So here and here. Let's try that again. So insert, this time Pareto. Good job. Thank you for catching it. Here's the Pareto chart. The Pareto chart is a statistical chart, by the way. This line right here is a cumulative line. I'll talk to you about cumulative tonight too, what that means. But what it's doing is it's taking the relative frequencies. It's taking these relative frequencies and it's adding them up. So here it started at, it's supposed to start at 0.5 and it works its way all the way up throughout the classes to add them up till you get to 1. All right. So it would start at 0.5, then add the 0.23, then add the 0.067. I'm sorry, 0.5, 0.023. Then it would jump over here and add this, and it would add these very last two at the top. The steeper the line is, moving, the more things you had in that class. That's what this is saying. So you see how steep it is from this first class to this point, right? From there to there. That's because you had a lot of things in that class. You actually had 15 in that class. But I don't care about the line itself. I do care about the chart. I know in your homework it's going to tell you to make Pareto charts, and this line is going to be on it. The line should always increase. It should always move up all the way, and it should always end at 100%. Y'all got that? Or at 1, or whatever the total is. I made this with a relative frequency. Let me make it the other way too. Here's the Pareto chart with relative frequency. Let me make it with frequency so you can see the difference. So I'm going to highlight these again. Highlight that, and this I'm going to highlight the frequency category. Insert. Over here by histogram, Pareto chart. And there. And so there goes that chart. And again, if you go to your quick layout will do things for you, like add these labels. I think it added something. That one added there. That one added the numbers inside of it. This one added the numbers going down it. But notice this line, these charts are the exact same charts. One has relative frequencies on the y-axis. The other one has frequencies on the y-axis. But they're the exact same graphs, all right? We need to be able to create those, the Pareto chart, possibly the pie chart, and the bar chart. But this is how you create it. You create that two-way table, and you really and truthfully, you don't need all of this information to create this. The only thing you need is a category. You need some kind of categorical variable. In this case, it's activity, where you have walking, weights, cycling, gardening, aerobics, and you need their counts or their frequency. So we have this category with these frequencies. We can create these graphs, all right? Now, I know that may have been fast for some of you if you haven't dealt with Excel, but again, I'm recording this video, so I want you to go back and watch the video. If you need help, let me know.
I was checking on that on the Blackboard, and I'm trying to find the first class, but where can I check the recordings?
It says recorded lecture. Look under the test. Look under the test one module. It should say recorded lectures. Test one recorded lectures. It should be in there. All right.
I have a quick question really pertaining to the, how did you select, like when I select multiple cells or multiple rows, it doesn't give me the option to make the table anymore, or the like the charts.
How many rows are you selecting? Are you selecting like 2?
No, I'm selecting like the walking, weights, cycling, gardening, aerobics.
Right. Like I'm doing mine, right?
Yeah, and then also the frequency.
So you select 2, but you're selecting 2 rows, right?
Yeah, I'm selecting 2 rows, 2 separate rows, and then when I go to insert, it's like the chart is grayed out.
Oh man. Hold on. So you're selecting like this.
Yep.
And then you come down and select this one next, right?
Yep.
Did you select anything more than that?
Recommended charts, I had to actually like click over into the other categories. It didn't automatically pop up in recommended. It was grayed out too.
Did you try like that?
Say that again, Autumn, sorry.
So mine didn't pop up under the recommended charts when I just highlighted those 2 rows. But if you go into like where the actual pictures are, where it's the bars, the pie, if you click on that, you can still make it into the chart. It's just not listed under the recommended for me.
So whenever I highlight the like walking, weights, cycling, gardening, aerobics, when I highlight that row, I can still click into the charts. But once I start highlighting the frequency row, all of those other pictures, they gray out for me.
That's like for me over here as well. All of mine are grayed out.
And so I can click the charts, but what it says is recommended charts doesn't support multiple ranges.
Same.
Do you have it, and yours looks just like mine? Your setup is just like mine?
Yeah, I mean, it's separate because I'm on a PC, but it looks exactly the same.
I got you, yeah.
Looks different because I'm using it from Outlook, from Office through the Gator Mail.
All right, stay back after this when we get done with the class tonight, and I'll have you share your screen with me, and I'll look at it like that, all right? And we'll see if we can troubleshoot it.
Thank you.
All right, cool. All right. So that's for this. Let's go to the next section in those notes that I gave y'all, the handout that I was going through. And we're going to talk about what happens when you want to compare multiple, like, so we just did one variable, which was the activity, and looked at its frequency. What if I want to add that second variable where it's Black, Hispanic, and white, and compare the activity based off those things, all right? So let's go ahead and Stop sharing that. And let's go to this over here. Share this screen. So let's share from this screen. There we go. All right. Let's talk about comparing more than one variable. In terms, we're going to talk about what's called a comparative bar charts. All right, our comparative bar charts. Two types of comparative bar charts. The first one we call a side-by-side, or a clustered bar chart is also known as a side-by-side bar chart. They're side-by-sides. You may see it written as side-by-side. And they're used for comparison. Typically, when we compare different distributions, we always use the relative frequency. The relative frequency is going to be what we use for comparing different distributions. So anytime you want to compare things, and the reason that we do it like that is because when you look at frequency, frequency is depending upon count. And by that, I mean that if you have more, for instance, in this particular case, we have the same amount of blacks, Hispanics, and whites. So we could just use frequency if that was the case. But most of the time when you do these things, you have a different number of blacks or a different number of whites or a different number of Hispanics. Well, if you have one group that's way bigger than the other, no matter how you try to compare it, the counts will always look bigger. So we always want to use the relative frequency to do it, the frequency with respect to the total. All right. And so the clustered or the side-by-side bar chart looks like this right here. Here's a side-by-side bar chart for what we just did. Right. That's called the side-by-side. This one is the clustered bar chart. And notice that the purpose of a clustered bar chart, we can tell by looking at this clustered bar chart, what's the most popular category? What's the most popular or the most preferred activity?
Walking.
Walking, right? Now, who walks more?
White.
Black, or Hispanic? Whites. We can look at that. That's what a cluster does, all right? Who does weights more? White, black, or Hispanic?
Hispanic.
Hispanic. So we can answer questions like that based off the clusters, right? Now, the other one we can talk about is what's called a stacked bar chart. And they're used to show the comparison of one category filtered on a specific category. In particular, so we are doing activity filtered on race. We're doing activity filtered on race this time. So if you look here, you can see that for each activity or for each race, what's the most popular activity? Again, it's still going to be walking, right? But now you can see that whites walk more than blacks, blacks walk more than Hispanics, right? But you can also go to the next one and see the next popular category, the next preferred category is going to be weights, where Hispanics do more weights than blacks, and it looks like blacks and whites do about the same amount, right? So this is saying. So we're just comparing things like that. And that's all this is doing is comparing, all right? It's just comparing. So we can make these graphs in Excel as well. We can make these graphs in Excel as well. So I'm going to go back to Excel one more time and show you how to make this graph. I think it's the last time I'll be in Excel tonight. So let's do that. Let's go over here. Share the screen again. Continue.
I put it in the chat, but just so everyone knows, like you can go into LinkedIn and they offer a training on Excel. I actually had to do it for my MIS class. So
I appreciate that. I appreciate that because again, I will tell y'all and be upfront and as honest as possible. I am not an expert in Excel. As a matter of fact, I would like to say novice, but I know a little bit more than most people in this class, so they may put me in charge. Just so y'all know. I don't want any of these charts anymore. All right, so we're gonna make a stacked or side-by-side bar chart, right? In order to make the side-by-side bar chart, what I'm gonna do now is I'm going to highlight all of this inside of here. I'm just highlighting the raw data, by the way. And again, when I highlight something like this, if I go to recommended charts, look what it automatically does for me. It automatically gives me my clustered bar chart or my side bar chart. And it also gives me my stack bar chart. So I can pick either one of these, right? And right now it's basing them off of activity. And within each activity, they give you the race counts, right? we can change this if we don't want. We wanted the race to be on the bottom, activity here. Over here, you should see a thing that says switch row columns. If I press switch row columns, look what it did. It changed the activity to be up here. So now I'm in my activities, and now I have my different races based on the activity. All right. So we can do it like that. And again, if you want to look at the other way, to switch row columns, it'll do it like this too. All right. So that is the side by side. If I want to do the stacked, again, highlight these, right? And then from there, I'm going to go to insert. If your recommended charts isn't working or you can't see that for some reason, you can click on these right here. If I want to stack, it'll read right there. There goes stack. And here goes the stack bar chart. And it's a stack bar chart based on preferred activity. But if I switch row column, I can do it based on ethnicity. I don't want this frequency. I highlight too much. Nah, I was about to say that. Yeah, I was about to say I actually highlighted too much.
I was confused.
I really just wanted to do these. My fault. This is what I wanted. Insert. Always try recommended charts first if you can, because it'll give you the recommended chart for it. If not, try to click on the other ones. If we can't figure that out, we'll have to try to figure something else out. But here goes that. And again, you can play with it, switch these around, see what they look like. Hey, notice when I switched it here, they're all at the same height. They're all at the same height, by the way. Why are they all at the same height? Well, you're looking at all the blacks, all the Hispanic, and all the whites, and they all have the same the same number of people, 10 in each one. That's why they're all at 10. There is a way to graph relative frequencies. I do not remember how to do it at the current moment, but I will find that for y'all, because there is a way to just change the frequency counts to relative frequencies. When I figure out how to do that, I will let you know. I don't remember off the top of my head. And I was supposed to look it up, but I got busy today. But I will show that to you for sure, right? But so far, here's what we've done. We've graphed categorical data, right? There are essentially two charts used to graph categorical data. They are the pie chart, which pretty much graphs part to wholes. And then there is the bar charts. The bar charts graph your frequencies and your relative frequencies and your height based off their heights, all right? If we want to compare, we can use a clustered bar chart or a side-by-side bar chart, or we can use the stack bar chart. For those, we should generally use, and when you want to compare, you always want to try to use relative frequency. In this case, we can get away with it because they're all the same total counts in the end. Generally speaking, though, you want to use relative frequency. And again, I will show you how to do relative frequency when I figure out how to find it again. Well, I'll look that up pretty soon. Are there any questions on categorical data? How to graph categorical data? How to organize it? Any questions on the end of that?
No, sir.
All right, good. So the rest of this will be over quantitative data. We're going to organize it tonight. We're not going to actually graph it. All right. So we're just going to organize it tonight. So let me get out of this. Stops here. Come back to the notes. All right. Oh no. All right. So when we talk about organizing quantitative data, recall that quantitative data is any data that can that uses numbers can do one of two things. What do they do? Can you remind me?
Count and measure.
Count or measure. Thank you. Count or measure. Right? And when they count or measure, right? Somebody got a lot going on in the background, you guys. Countable data. is also called, we count the data. What do we call that again? Can you remind me? Can y'all remind me what we call countable data?
It started with a D, I think.
You were right, it did start with a D. What's that word?
Discrete? No.
Good.
It
It's called
is?
discrete.
Oh, okay.
It's called discrete. So we have countable data is also discrete data. And what makes it countable is that the data must be a whole number. The data must be a whole number. So when we count, we use whole numbers. Everybody got that? Measurable data is also called continuous data. Continuous data, right? And continuous and can be in fractions or part. So what we're going to do now is when we have numbered data, we're going to organize the data in what we call a frequency distribution. A frequency distribution is just a table that organizes the frequencies of quantitative data into, we'll call them, I'll call them intervals, but you may also see them called classes. All right, you may also see them called classes. And then here's what we have, and I'll come back to that last statement in a second. So it says the following data represents the cost in dollars for 4 tickets, 2 beers, 4 soft drinks, and 4 hot dogs, 2 game programs, 2 baseball caps, and parking for 1 vehicle at each of the 30 Major League Baseball parks during the 2012 season. Here goes those costs, right? So in this table, I have all of those different costs, right? Where the smallest cost is 146, and the largest cost is 337, right? 337. So here's how this works. When I talk about a frequency distribution, I'm talking about numerical data. This is numerical data. Is this continuous data or is this discrete data? Anybody? Continuous or discrete?
Discrete.
Try it again.
It's continuous because it
It's
has
continuous.
follows
Because it has what?
You said something like if it has something that follows it. So like with this, it's talking about money. So it's
Good. So it's
dollars.
units of measurement. It has a unit of measurement attached, which is dollars. It's $146. The data presented to itself, the data is presented in a discrete manner because you're only given whole numbers. But I want you to realize it's technically continuous data because it's $146 you're measuring based off a unit of measurement. All right. But if you said it was discrete, that really isn't the problem here. So when we graph this though, because it's numerical data, we're going to create these things that we call classes, or also intervals. They're just intervals. And what we're trying to do is capture values now. Here's how the classes work. The true way you're supposed to do this is you're supposed to find how many classes you want, right? How many classes you want. Generally start with how many classes you want. In this case, we have 1, 2, 3, 4, 5, 6, we have 7 classes, right? So if I want 7 classes, here's what I'm going to do. I'm going to look at this data. I'm going to take the largest number and subtract it from the smallest number. What do you call it when you take the largest or the smallest number, subtract it from the largest number? What do you call it when you subtract the min from the max? Anybody?
Range.
The range. So I'm going to find the range first. So in this particular thing, what I'm supposed to do is find the range first. So I'm going to take 337 and subtract it from 146. And when I do that, I get 191. So I know the range is 191. Now, I know I want 7 classes. So I'm going to do this. I'm going to take 199, 191. I'm going to create what's called the width of each class. How big is each class going to be? So I'm going to take 191, the range, and divide it by 7. And I get this, 27.3, approximately 27.3. So what that means is that every width, in order to span, and when I talk about span, what that means is this: I want the lowest value to fall in the class, and I want the largest value to fall in the class. So to span the data set, I have to use an interval of 27.3. Well, 27.3 isn't a very nice number to add with, at least. So we want to make this a nice number to add with. So if you look here, how big is each one of my intervals? I go from 140 to 170. How big is that interval? Can anybody tell me?
30.
What about from 170 to 200?
30.
So how big is every one of my intervals?
30.
30. And I'm picking 30 because 30 is a nice number. Generally by nice, I mean a multiple of 10. some multiple of 10, so something ends with a 0 that spans the actual intervals based off this number. So I went to 30 for mine, all right? Now, you could have went to 40 if you wanted to. You would have had a class with nothing in it, but you could have did 40. What I'm telling you is it's kind of subjective on how you make this. On your homework, it'll tell you what they want. Especially on my math lab, it tells you what you want. I'm not going to ask you to actually make this unless I give you exactly what I want you to do it. And what I mean by that, I'm going to tell you how many classes I want. I'm going to tell you what interval I want. And all you would then you would fill in these, what we call the upper and lower bounds. And here's how this works. We always include the lower bound. We always include the lower bound and we exclude the upper bound. I don't know if y'all know algebraically what that means, but this symbol right here means to include. The bracket means to include. The parenthesis means to exclude. So that's why if a number is 140, it falls in this class. If it is 170, it moves to the next class. So we're always including, excluding, including, excluding. So you always include the lower bound and exclude the upper bound. Everybody got that? That's why the lower bound keeps repeating throughout. All right. So in order to do this, then here's what we're going to do now. We're going to find the frequency. And the frequency works like this. Your data needs to be ordered. Notice here, my data is ordered. Go down the actual columns and you can see that it's ordered. 146, 150, 150, 152. They're in order like that. Everybody got that? So the first thing that we do is we start with the data ordered. And what we're going to do now is find how many values fall between 140 and 170 in this data set. So we need to go find those values. So how many values fall within 140 and 170 within the data set? Yeah, help me do that, all right? Thank you.
6.
So I have 6. I have 1, 2, 3, 4, 5, and 6. So all I'm going to do right here is write the frequency of 6. How many fall between 170 and 200? 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 10. Y'all got 10? 5, 6, 7, 8, 9. Yep, 10. How many fall between 200 and 230?
7.
Thank you so much. 1, 2, 3, 4, 5, 6, 7. Why do I not include 230 there?
Because we always exclude the top.
Good. Exclude the top, include the bottom. Good. Exclude the high, exclude the low. Include the low, exclude the high. My fault. So this is 7. Next one. 230 to 260.
4.
1, 2, 3, 4. 260 to 290.
None.
None.
None. Good. That is a 0 count. And then the last one would be what? 290 to 320. I thought that was the last. That one's going to be how many in 290 to 320?
1.
1.
1. That's at 300. So we have 1. And then the final class we have what?
2.
Color my pink. There we go.
2.
And the final class have how many? 2,
2.
right? There you go. 2. Now, this is the frequency, all right? We can use the frequency. What's my total, by the way? What's the total there? 6, 10, 7, 4, 1, 2. What's that add up to? 16,
32.
23. It should be 30, I thought. Maybe it is 32. 16, 23, right? 27. It's 30.
It's 30.
It's 30. All right, cool. So this is 30. Total is 30. Now, from there, we can find our percentages. How do we find the percentages again? Well, percentages means you're finding the relative frequency. I got that. So the percentages list a percentage distribution, which is going to be the next column, lists all of the relative frequencies of the intervals in the percentage. So if I want to find the percentages, all I'm going to do is do 6 divided by 30, right? 10 divided by 30. 7 divided by 30. 4 divided by 30. 0 divided by 30. 1 divided by 30. And 2 divided by 30. And now I'm going to actually calculate those as percentages, by the way. Six divided by 30 is 0.2. Let's go black. So this equals 0.2. 10 divided by 30, 0.33. And actually, I want to write them as percentages, not like that. So let me rewrite them. Man. Oh no, it didn't kick me out. All right. So again, this one was 20%, 33.3%. What is 7 divided by 30? 23.3%. 4 divided by 30. 13.3%. 0%. 1 divided by 30. 3.3%. And 2 divided by 30. 6.7%. There goes your percent distribution, all right? That's your percentage distribution. So 2 graphs I just made right there are 2 different tables I made. The frequency distribution, which consists of frequencies based off the classes. The other distribution is called the percentage distribution, which consists of the percentages, which are relative frequencies, all right? The relative frequencies are part to whole, remember that, right? So y'all okay with that? Making those 2 particular columns so far?
Yes.
Yes. All right.
Yes.
Let's look at the last one then. Cumulative percentage distribution. Let's talk about that. The cumulative percentage distribution. The cumulative percentage is the percentage of observations that are summed up to a particular class. So you're going to sum these up to a particular class. And we can use the cumulative percentage to find what are known as, here's the key thing that we're going to get to, percentiles. All right. And a percentile is the percentage of values that fall at or below a specified percentage. The percentage of values that fall at or below a specified percentage. All right. And so when we talk about percentiles, here's a percentile you already know. You know what the median is a percentile. And you may call the median the middle number. Remember, when we said the middle number is really means that you have 50% of the values fall at or below that, and 50% of the values fall above it, all right? So these are what we call percentiles. That means that in the median, 50% of values fall at or below, and the other 50% fall above it. But in general, we mean at or below. And I'm gonna get more into this when I talk about these bottom examples, but we're gonna go and fill out the cumulative percentages now. Here's how we find cumulative percentages. We start off with whatever the first class is. In this case, the first class has 20%. So we're gonna start off with 20%, right? Now, a cumulative percentage means that you're adding up to the next class. It's kind of like your semester GPA versus your cumulative GPA. Your semester GPA is what you make for just that semester. Your cumulative is what's been adding up over the entire thing. So when we do this, we're going to accumulate what comes up next. So we're going to add 20% plus 33.3%. What does that equal to?
53.3.
0.3%. Thank you. Next, we're going to add 23.3% to the next one. So what does that one equal to? 76.6%.
76.
Then we're going to add 13.3% to the next one. That's equal to what? Feels like
89.9.
Thank you for so much. Then we're going to add 0. So what's in the next one then?
89.9.
89.9%. That doesn't change. Add 3.3. What do we get next?
93.2.
Thank you so much. And then we're gonna add 6.7, and then it'll add up to what?
99.9.
99.9, which is pretty much what though?
100.
100%. That's 100%, all right? So this, we'll call this just 100%. We didn't get exactly 100 there because we had round off error. Everybody got that? We had round off error. So now here's how we use this then. We're gonna talk about these percentiles. We're talking about percentiles. If I ask you, in what class does the 25th percentile fall? What am I asking you to find? What am I asking you to actually for the 25th percentile? I wanna know, where do 25% of the values fall at or below, right? Where do 25% of the values fall at or below? And so I'm gonna go in here and I'm looking for 25%, but I don't see any class that has 25% yet. See that? So
But it's
look,
connected
where does
to
20?
the second group.
Good. It's connected to what group?
It's 170
Color.
to 200.
To 200 blue.
Like the 170, 200. So it's the blue group, right? It occurred somewhere in here. So this one came in the blue group, which was 170 to 200. We don't really know what the value is that creates it, but we know that it went from 20% here to 53. So it had to fall somewhere in this class right here, right? What about the median? Where does that fall at? What class does the 50th percentile occur?
Same class.
Same class. It also occurs in the same class. And in what class does the 75th percentile occur?
200 to 230.
200 to 230.
Good. The very next class, right? 200 to 230. And that's how you do that, all right? That's how you determine based off the classes. And that is how we organize quantitative data for right now. The next thing we're gonna do is quantitative data is make graphs. We're not gonna do that tonight though, all right? We're gonna call it a night there. Everybody got any questions?
I have a question, Professor.
Yes, ma'am.
The cumulative percentage, how did you get that? What did you, how did you
The
get
cumulative percentage?
Yes.
Cumulative? Let me go through it again because I did go through it kind of quick. Starting here, take this the first percentage and move it over. So that's 20%, right?
Okay.
To get to 53.3, look what I did. I took 20% and added what to it?
Okay, 33.2%.
And that gave me 53.3. To get here, how to get to 76.6? I took what was right here at 53.3 and added what to it?
23 point. Is that a 5?
23.3.
Oh, 3. Sorry. Okay.
And that gave me 76.6, right?
Right.
Then I took 76.6 and added what to it to get to the next one?
13.2.
Yes.
Okay, I got
89.9. Okay, good. Anybody else have any questions about that? Thank you for making me slow down on it. I did go through that kind of fast, assuming y'all knew what I was talking about. That's my fault. Any other questions?